Hi, this is the second part of this week's pre-lectured video, and we'll talk about system architectural design. So this is about architecture. Architecture is, you can think of it as the blueprint of something you're going to build. So an architecture, uh, it means you're not worrying about too much about details at this point. So you forget about the details. You care about the main structure, the most important part of the system. And many things that we're going to talk about system architecture uh, can apply to the software. Like what we have been talking about in this chapter is systems engineering. So it cover hardware, software, as well as people aspect. So not just software alone, okay? But our discussion actually can apply equally well to systems as well as just software. So the first thing we want to do to arrive at an architecture is to try to decompose. It means break down. Okay, it means to break down the system into a number of subsystems. So subsystems and systems, they're actually quite similar, but it's just that subsystems are smaller and they are part of the bigger system. These two terms, we'll see that again and again in software engineering. Cohesive, a subsystem is cohesive, is the components inside the subsystems are closely related. So they are not just randomly you throw different components, unrelated components together. That if they're not related well, then even you put them together, they are not cohesive. So cohesive means you really make a good decision of knowing what things are related and then you put them together in a subsystem. So a good design is also a cohesive design. And loosely coupled is another aspect of a good design. It means, okay, if you have two subsystems side by side, then the way they interact would not be too complex. Okay, if they interrelated in many complicated ways, then we said those are tightly coupled. So loosely coupled and tightly coupled are opposite. So loosely coupled is a good design. That means things between two different subsystems are not so related. So you can see these are actually two sides of the things. Cohesive means components inside a subsystem or a system are closely related, okay? But loosely coupled means things crossing the boundaries of two subsystems are not too closely related. So we want things to be closely related to be inside a subsystem. Things that are not very closely related in different subsystems, it makes things much easier. Uh, so when we build a system, it will be a lot easier. And also, after breaking things into subsystems, we want to be able to use off-the-shelf components. Okay, for example, maybe for our airport baggage handling system (ABHS), we want to use some existing barcode readers to help us identify luggage. Okay, so we know from the barcode we know uh, which passenger, okay, which traveler is the owner of that luggage, so that we know where the luggage should be sent. Should it be sent to San Francisco or Chicago or Toronto or New York? we want to know the exact location. So using existing off-the-shelf components can lower our cost and often improve our quality, because if the product has been around for a while, someone has been using it. So from comments of the previous users, we can tell whether it's a good product or bad product. So maybe there are several barcode readers on the market. Then we, uh, as the builder of this ABHS system, we can choose a good barcode reader. Okay, and also definitely it's going to be cheaper to build our own barcode reader. So that's what we are trying to do. So decomposition, breaking things up, and requirements, things we want to achieve, the responsibility, the task will be assigned to different subsystems. So a team that's building a subsystem will look after that requirements. And to help people better understand the architecture, we often use diagrams. You can almost imagine the case of buying a flat, 買屋咁樣, okay? Lots of time, if you draw the floor plan, like how big is the living room, where's the window, and what's the layout of the flat, where is the kitchen and bathroom, how big they are, if there's a window in the bathroom or something like that. They are all key thing, architectural things. So we can use diagram to enhance our communication between the team members, or between team member, a developer with the customer. So how do we do system decomposition? So these are some of the guidelines, but actually we have been touching on it already. Okay, after dividing up a system into subsystem, then each subsystem can be assigned to different team to look after it. Okay, and some components may be off-the-shelf part, cheaper, sometimes more reliable, and okay, we would also assign different requirements to different component, and the functionality of a subsystem should be clear, well described, clearly defined, easy to understand. And subsystems between two different subsystems, they should be independent. Okay, that is due to the fact of them being loosely coupled. Okay, if they are the opposite, tightly coupled, then they are highly dependent of each other. So that is not very good. What's the purpose of having loosely coupled design? That means you can assemble two subsystems, integrate two subsystems together very easily. If the interface is very complex, then it's very hard to put them together. So this is there are 5 strategies to decompose a system listed on the textbook. You can decompose by system function, by engineering discipline. So what kind of developers team, the team required to build that part, so that each part that requires certain field in the engineering, for example, hardware, you assign to hardware team, software, you assign to software team, something like that. And decompose the system according to existing architecture. So if you already have a system, you are just modifying it, then you probably it's a good idea to just make good use of the existing architecture, existing high-level design. Decompose the system according to the functional units of organization. For example, if a company has different department, then maybe you can assign a subsystem to one department to do. So that's what this means. Decompose the system according to models of the application. That basically means some sort of combination of the above. So based on the design, how you break things up, you decompose it. Okay. So this is an example of based on some functionality, you keep dividing the whole system, major function, and then major function is actually made up of several smaller functions, and so on. And this is by dividing it by hardware, software, and so on. And this is, I think, HM, the author probably referred to human system, human aspect of it. Okay. Okay, let's look at the example of our airport baggage handling system. We have a requirement to handle check-in of luggages and transporting the luggage to departure gates and the baggage claim areas according to the destination of the passengers. So that means let's say if we're building baggage handling system for the Hong Kong airport, and a passenger is flying to Tokyo, then the person should be able to check in the luggage in Hong Kong and then go to the baggage claim area in Tokyo to get the luggage. Okay, so this is the high-level requirements, which we can divide it up into three smaller ones. For example, it consists of checking in luggage with the airline staff, okay, at the counter. You check it in, and then the handling system will transport the luggage to the destination within the airport. And finally, the system should, there's a spelling error right here, okay, should control the transportation of the luggage within and between the terminal. Okay, so what's the difference? So I think this is maybe from airport to airport, or this is there may be multiple terminals in the same airport. Terminal 1, Terminal 2, I think Chicago has 3 terminals. And this one, we divide it up into 5, even smaller. Okay, so it's almost like right here, we can divide it up 1 level and 2 level and so on. Transport luggage from check-in areas to departure gate. So this is still in Hong Kong. And so this part is probably, we're talking about the case of from Hong Kong to Tokyo, then this will be from the arrival gate, the plane has landed, then it's parked in the airport, then the luggage will be transported to the baggage claim area in Tokyo. And of course, this only refer to from from the same airport, right? This happens to the Hong Kong airport check-in area to the just before the plane take off, and this is from where the plane has landed to the baggage claim. And this third one is from arrival gate to departure gate. Okay, that means it's from Hong Kong airport to Tokyo airport. And this part refers to the transportation of the luggage through the conveyor's belt, 输送带, from inside the terminal. Okay, if it's inside the terminal, we can use the relatively slow conveyor belt. But sometimes, if we need to transport something from one terminal to another terminal inside the airport, then we would use some destination coded vehicles. I can show you a picture of that destination coded vehicle. Let's see, do we have a picture? Right, so the luggage would be put here, and then it will go faster than a normal conveyor belt. So all these from Hong Kong to Tokyo, actually we can break it down into different parts, because like even from the check-in counter. So all these, if we're missing one, then actually this would be a bad decomposition because we're missing some component. But by breaking it up, then it's easier to tell. So from Hong Kong check-in to the plane taking off, and so on. Okay. This is another requirements that apparently this is for a small airport that only needs to serve 20,000 passengers a day. There are a lot of small airports like that around the world, because Hong Kong is a big city, so that's why these 20,000 passengers look rather small number. Okay, so we can break it up into say check-in area handling maybe 1,000 or so check-in luggages. But of course, an airport may also have multiple check-in areas, so we also may want to list them out here. And also this would have some assumption, or for a check-in agent, the staff can check in 3 passengers per minute. Okay, and of course we also want to know how many check-in staff can be working concurrently, okay, that our system can handle. So these 4 components together make up this. Of course, it clearly requires some knowledge of the business, of the like hardware, software, or people operation. So we have to have some knowledge in order to produce good decomposition of high-level requirements to lower level requirements. And someone will have to check to make sure that the sum of these smaller requirements actually make up the big one. Okay, if some numbers are totally off, then maybe it cannot add up to the big number that we want to handle. Okay, for example, if the number of check-in areas that the system can support is small, like let's say 10, okay, if there can only be 10 check-in areas, so 10 times 1,000 is like 10,000, so it won't quite meet this 20,000. Of course, there also may be some assumption of how many luggage of a passenger has, because this figure refer to the luggage and this figure refer to the passenger. So we need to do some calculation, conversion, and things like that. But you get the idea of how to work with requirements at the system level. And that concludes our part 2 of this 3-part pre-lecture video.